right, triangles and trigonometry. What we went over last time was just talking about Pythagorean theorem and what that's used for whenever you're given two sides and you want to find a third side. Special right triangles are going to be important because they're going to be rules that you can identify things with, and they're just basically shortcuts. So just know that you have a 30, 60, 90. If you see 30, 60, just know the other one's 90. You see 45, 45, see 90. If you see 90 and 45, just know the other one's 45. So what we went over last time was talking about the hypotenuse, the opposite, the adjacent, where those are located and everything like that. So just to do a quick review, whenever you're going to find sine, cosine, or tangent, what we're doing is whatever angle you're looking for, there's the opposite. Whatever is connected to the angle as well. So here is the angle. Whatever is connected to it is adjacent. And the reason the other one's not adjacent is because that is the hypotenuse. That's where the right angle points. So really these all take care of themselves. There's only can be one way that can go. Just to review also the SOHCAHTOA. Okay, so what we want to do is look for the last one, and that's going to be able to set up our ratio. So we're given an angle and a side, which means that we are not using inverse. We are using sine, cosine, and tangent. It looks like you're given the hypotenuse, and depending on what you want to find, do you want to find the opposite or do you want to find the adjacent? Let's go with opposite. That's going to be opposite of the angle. So we're going to put op right there, and let's use this one. So sine with the angle measure 34 is going to equal the opposite over 25, which is our hypotenuse. Multiply by 25. Multiply by 25. And this is what you're going to be typing in your calculator. 25 times sine at 34 degrees. Another example, and the only thing that changes here is that you're given the opposite side. You need to find the hypotenuse. And you are, oh wait, actually this is the adjacent. This is opposite. So wherever the angles are pointing, that's where you are going to label your sides. It does matter. So let's jump ahead over to, well, how do you know when to use the inverse of sine, cosine, and tangent? And that can also be labeled as arc sine, arc cosine, arc tangent. It would look like this. That's arcsin. And that is the same exact thing as this. And you don't ever have to raise it to the -1. It's just saying that this is the inverse of it. So when the heck do you do this? When given two sides and you're looking for the acute angle. So if you're given two sides and you're looking for an angle, that's where this would break down. So on the other one, when not the inverse, I guess the inverse of the inverse, sine, cosine, and tangent, you're given an angle measure and you're given a side. This is when you're given two sides looking for an angle. You can see that because you don't know the angle. So let's see how this actually breaks down. So what we have here is, I want to figure out what A is, right? So what I have to do is I have to find the inverse. What that does is it'll isolate this angle measure. Typically we'd have this angle measure put in and we'd be missing this one. So here's how we're going to go about doing it this time. We're going to multiply both sides by the inverse. And this is how you end up getting the inverse sine, inverse tangent, inverse cosine. So that'll get rid of sine, and then we have angle A is equal to the inverse sine of 12 over 25. That'll tell you what your angle is going to equal. So what does that look like whenever we type it into a calculator? That's what we're going to work on in just a moment. Let's go ahead and take a look. Let's see, best scientific calculator. Okay, so what we have here is I'm going to invert it. Inverse sine of 12 divided by 25. Oh, it's supposed to be degrees. Give you about 28.7 degrees. So what that's saying is you're going to have an angle of about 28.7 degrees. The only thing you need to remember is that whenever you're given two sides, you're using the inverse sine. You don't need to go through this process right here. This is the process of why it works. So just to do a couple of these jumping around, you can see that you're given two sides and you're missing an acute angle. And the reason it's acute because you're given the right angle, and the reason that this works is because you're identifying it as a right triangle. So I'm just going to go ahead and go over to SOHCAHTOA. Okay. If you're not writing this mnemonic down, then there is a major piece you're missing. This is the tool that allows you to answer all the questions. So let's do 9 and 10. Okay, so I'm just going to highlight those. All right. So what we're given is so we're missing a hypotenuse. Okay, so H is, I don't know. We have opposite and we have adjacent. Notice how I'm labeling those. Even though I don't necessarily need to, it's a good idea to go ahead and label all the stuff that you're given. That way you're not getting the pieces mixed up. So let's see, if I have opposite and adjacent. Okay, opposite, adjacent. So I'm thinking we go with the tangent. I'm going to explain more about sine, cosine, and tangent, about being x and y, and how tangent is your hypotenuse. That's why we're using tangent, because we're missing a hypotenuse. So it'll help us find this angle whenever we use the inverse tangent. So what this could look like is tangent to the negative first, or arc tangent. I'm going to stick with arc or tangent to the negative 1 because arc tangent is the same. And we're going to have our question mark, which is right here, equal tangent to the negative first, and we have opposite 27 over 38. Wow, that's messed up. Okay, and then go back to the calculator. So it looks like we have an inverse tangent because we are, see the atan, arctangent. This is the same thing as tangent to the negative first, which is just the inverse. Make sure you're always in degrees on your calculator. If you're coming up with some weird answers, because it's in radian. I'll go ahead and show you what the weird answer looks like in radian, but make sure you're finding degrees all the time, whether it's inverse or not. And I already forgot what we're doing. 27 over 38. Okay, so about 35.4 degrees. So the angle we're looking for is about 35.4 degrees. Let's see if that's right. Hey, look at that. Okay, cool. So the process is not crazy. It's not anything super wild or anything like that. All right, so we're going to use tangent again because look, we're missing a hypotenuse. Hypotenuse is tangent. So we're going to go opposite over adjacent again. So tangent opposite right there, adjacent right here. So negative first equals 9 over 21. You can simplify this. 3 goes into 9 and 21. So, I mean, these things can be done. 3 goes into 9 3 times, and 3 goes into 21 7 times. So now you have the tangent, inverse tangent, so the angle is going to be whatever 3/7 is. So let's just go ahead and use the calculator. Inverse tangent of 3 divided by 7. 23.2. And here's what it looks like in radian. So if you're sitting there getting that, whenever you're using inverse, go like, holy, I got to go to my calculator menu and switch it to degrees. Oh, there it is. Okay. So anytime it looks like that, just know that you need to check your calculator for if it's in radian or degree. So I already forgot what it was. 23.2. So we're looking at about 23.2 degrees. Let's check it. Hey, look at that. All right. So that's the process you're going to go through for those. It's obviously not much different. All you have to do is identify, am I given two sides and looking for an angle? If the answer is yes, inverse. Am I given an angle and a side? If the answer is yes, sine, cosine, tangent. Use SOHCAHTOA and find the answer that's most appropriate for you. I also want to touch on geometric mean. So geometric mean is a way to use similar triangles. If you're given a right triangle, you can cut it into pieces that will make similar triangles. And then you can use proportions to get those things. Whenever you use a proportion, it turns out to end up with a formula like this. This is how you find geometric mean. So if you use one huge right triangle, you can make it into two similar right triangles, which gives you three triangles. I know that that's weird, but I'm going to show you a picture. I just want to show you how simple it is to use geometric mean. So say that you had 8 and 18 for geometric mean. You would do this. 8 times 18, and you'd find the square root. Okay? So your teacher might tell you to simplify that, but what we're going to do is we're just going to solve for it. So the square root of 8 times 18. It's 12. Okay? That's it. We just found the geometric mean. So x equals 12. So I know that there is no practical use for this right now, but this is just how you use it. You're like, when do I use it? Why am I using it? So let's do 20 and 25. So geometric mean, the square root of 20 times 25. Square root of 20, 20 times 25. About 22.3. 22.3. That would be the geometric mean of 20 and 25. Okay? Now, what the heck? Why? All right, so here is the original right triangle. Okay? And then whenever we use a line of altitude, which is cutting through the right angle of the original triangle, we actually create another right triangle. Actually, two more. I'm going to highlight those, giving us a total of 3 right triangles. All right, so geometric mean. Simple way of going about it is what we just did back here with 8 and 18 is what 12 and 8 is. And what we're going to do is find x. So x equals, see look, the square root of 12 times 8. Let's go to the calculator. The square root of 12 times 8. About 9.8. X is equal to about 9.8. That's it. That's all. Now, there is a variation of this that can be confusing. Like, for example, if you are trying to find a hypotenuse, there's going to be 2 sets of triangles. You're going to use this one. Then you're going to use this one. So the orange one would find x, the red one would find y, and then if we use green, that would find the altitude. Okay? So let's find x. And here's where this variation comes in. If these are similar triangles, we can set up proportions. And what you could do is redraw these triangles and then use corresponding sides to set up a proportion to find the missing side. So x is going to look a little bit different. Okay? So what we're going to be doing is finding this compared to the whole thing. So it's going to be, since we're looking for the hypotenuse on x, we're going to be looking at this triangle compared to the entire triangle. Okay? So the 4 is going to be compared to 6 plus 4. Okay? So let me see what that looks like. And the way you're going to get this is by practicing. 6.3. We'll go over this more in depth, but just failing over and over and practicing this is going to be the way to go about doing it. So whenever we go over it in tutoring, that'll be a major part. I wanted to just touch on it. I don't want to get too far into it today, but that's a preview of what geometric mean can be.